So here we are recording, and we're looking at my little amethyst here, the chevron amethyst. Okay, there it is. Got chevrons, and one of the first things you learn about the striations on quartz is that quartz only has horizontal striations. So I suspect this is probably not quartz. And what I'm looking at here is looking at the color. Okay? Because what quartz has is a little bit of iron, I think, or manganese or something, or maybe both, that causes that purple color. But that purple color in this particular stone seems to be kind of nebulous. Look at that. I keep looking for it, and when I turn the stone that way, it kind of moves away, kind of goes somewhere else. And if you look in here, look at the differences. Look at that. And what we're seeing there actually is light coming here from my light, my white light, and it hits the carbon. Okay, and the size of these striations changes depending on the depth of formation. Okay, the deeper it forms, the closer together they are, and the darker blue the diamond. And that's what that is. That's not purple, that's blue. You can see that, it's blue. Secondary colors are purple. The secondary colors are that kind of reddish color mixing in there. But the primary color, when that light passes through that stone, is a nice, even dark blue, but it's not very consistent, is it? It doesn't follow all the way down here to the bottom, and when you look through here, it's extremely nebulous and hard to find, and see, if I had a purple stone, and I sanded a bit of it off onto a piece of sandpaper. Let me see if I have some. Okay, so we've got a little bit of sandpaper here, or a sanding disc, a grinding disc. That's brand new. There's nothing on it. I just pulled it out of the package. And somewhere, where did my damn rock go? Uh-oh. Hold on. Okay, so we're going to try a little experiment here, because when I grind on this, if it'll grind, what I'm gonna do is take a little bit off of the bottom here on the very, very point of this thing, and we'll see what color it is. If I take that and run it on this stone, what I end up with is a gold light gold streak. And because this is AUPT, it's gold platinum alloy, and when I grind on it, the gold and platinum turn into little tiny bits of stuff, and they adhere to my disc. So I'm gonna hold again. Okay, so we've got a disc here, and we've got a little patch here where I ground some off. And you can see that it's white, it's not purple. White, because it's actually clear. It's clear. And the closeness together of the unit cells, the smallest group of atoms, changes depending on the depth of formation. Also, depending on the depth of formation, the amount of carbon-14 changes. The deeper they form, the more carbon-14 there is. So what we have is a little bit of radioactivity. That's what that is. It's giving off beta particles. Carbon-14 is activated by light. Light hits that carbon-14 and it starts vibrating at the same wavelength that the light that's exciting it happens. So like on a really clear diamond, it'll glow any color of the rainbow. Now with blue diamonds, because they're so close together, only blue light activates them. But I do actually have a blue laser somewhere around here, and when I hit it with a blue laser, it lights up the entire stone. And the entire stone glows, not just blue, it glows that purple, violet, red color that diamonds fluoresce in. Because that's what it is. It's a carbon crystal. It has four-sided symmetry in one direction, and 90 degrees out of phase from that, it goes to six-sided symmetry, but it's not hexagonal. It's not hexagonal because hexagonal is two even axes, 1, 2, and one long axis, 3. And this is one axis here, and here, and here. It looks like the corner of a box because it's cubic. And my little grinder shows a little bit of white dust on there, just a little bit. And what those are, little tiny diamonds. Bits and pieces of diamond that break off exactly along the planes of cleavage. Because all carbon atoms are the same size. And they all line up in perfect little rows and columns. And that's why they have planes of cleavage. And when you look through this stone, you'll see, let's see, I think I probably better turn it around. What you're seeing in there is planes of cleavage. That's what those are. And they're associated with the striations on the outside of the crystal. Quartz doesn't have planes of cleavage. Quartz can't have planes of cleavage. And quartz doesn't glow. What happens when you pass a laser through a glass bottle? If I put my laser up there and I went, is my whole bottle gonna light up? Or is it just gonna pass right straight through? It just passes right straight through because it's just glass. Doesn't do that with these. Because they're not silicon dioxide. They're carbon. And they have a little bit of carbon-14. And that's what makes diamonds glow. That's what makes them sparkle. And that's what gives them the color. How about that?